Okay, so the topic today is topic 6, electric and magnetic fields. Okay. So the first word is electric and the second word is magnetic and the third word is fields. Okay. Before talking about the electric and magnetic thing, the first thing that we want to understand is the word field. Field. What do you mean by the word field? Do you know English?
Yes.
Okay. So in English,
Yes.
do you know how to use the word field?
A region of area.
Region, area, and if I ask you the question, in which field does your father work?
Oh, chemical field.
Chemical engineering,
Yeah.
right? He is a kind of, you would say he's a chemical engineer. Okay. What according to you is my field?
Teaching field.
Teaching, education. So it means that when it comes to chemistry, your father has some kind of influence. He can tell somebody something about the chemistry. He can tell somebody something about what kind of engineering goes on in chemistry. When it comes to me, I can tell you about how to study physics, right? To get good scores in your exam, so on and so forth. So when we are talking about the field in this context, we try to understand that what kind of influence do I have, right? Now we have a word electric and another word magnetic. Do you know? When somebody says it's electric, what do you feel? How do you know whether something is electric or not?
It involves charges.
It involves charges, right? And when it comes to the word magnetic,
It involves poles.
poles, right?
No.
So let me give you a bit of perspective. In the early days of science, we did not know that there's something in this world like charges. But we did a kind of an experiment in which we took a glass rod and we took another glass rod. We had two glass rods, okay? Then we rubbed this glass rod with a silk cloth, okay? And this one also with silk cloth. After we did the rubbing, we saw that there was a kind of a repulsion between them. They were not repelling each other before, but they started repelling after we
Scrub them.
scrubbed them with a silk cloth.
Yeah.
The same thing happened if we took two other rods, ebonite. Ebonite is a kind of material that you would see beneath the nib of a fountain pen. Okay? Have you ever used a fountain pen?
No.
Have you ever seen one?
Yeah.
So when you would see a fountain pen, you would see the nib of the fountain pen,
Yeah.
and beneath the nib you would find a kind of a black material. That's usually made of ebonite. Okay. So if you take two ebonite rods, and we do the same kind of thing, we rub these ebonite rods with
Silk.
cat fur. Cat fur, right? Cat fur.
Yeah.
Then we saw that they are also repelling each other. Okay? Got it? What do we understand on the basis of this experiment? This experiment tells us that after we rubbed the glass rod with silk, they started repelling each other. That means they achieved some kind of property due to the rubbing.
Yeah.
The same thing happened with the ebonite. But when we look at a particular thing that happens to be on the trees, that's amber. Do you know what is amber? Have you ever seen amber?
I've seen the color amber. I don't know.
Amber. Let me show you amber. Okay? What's amber? Amber is something like that. Amber. You see, this is amber. What does it look like? Does it look like a gemstone to you?
Yeah.
Right? Do you know where do we find it? We find it on trees. Okay? And how do we get amber on the trees? So for example, there's an insect that is dying on a tree, the tree is going to release some kind of gel, resin, and it's going to engulf the insect, and then it's going to get solidified. So if you're going to see an amber, you will see an insect inside, the fossil of insect inside the amber. And this amber has this special property that when you're going to rub it, it's going to repel each other. Okay? Now, this amber is known as electra. Electra in Latin, right? Okay. In the Latin language, we call amber as electra. And this electra, this amber, is specifically known to repel each other when it's being rubbed, right? It has such a great tendency to repel each other when it's being rubbed, right? So this electra has a certain behavior. What kind of behavior that is? That when it is rubbed, it starts repelling each other.
Yeah.
Okay. Now let's look at this glass. Is this glass behaving like this electra?
Yeah.
Can we say that this glass is electrified?
Yeah.
Okay. Now you understand where the word electrified is coming from?
Yeah.
Okay. What can you say about this ebonite rod? Is it also electrified?
Yes.
Both of them are electrified.
Yeah.
Right? Now, the thing is, the glass rod and this glass rod are both run by the silk. So the kind of electrification that we see on this glass and the kind of electrification we see on this glass has to be the same.
Yeah.
The similar electrification. And we see that they are repelling each other. Okay? And what about the ebonite rods? Are we doing the same thing with these two ebonite rods?
Yeah.
They are also electrified similarly. They are also repelling each other.
Yes.
Right? So based on this experiment, what can we say? That when two objects are similarly electrified, they repel each other.
Yeah.
Okay? And when they are repelling each other, we bring the glass rod near the ebonite rod and we see that there is a kind of attraction between these two. Okay? So the glass rod and the ebonite rod are kind of attracting each other. Right?
Yeah.
Now what can we say? Can we say that the glass rod and ebonite rod are similarly electrified or differently electrified?
Definitely. Yeah.
Yes. So this experiment tells us about electrification. What do we understand by the idea of electrification? Okay?
Yeah.
And why exactly do we call it electrification?
Yeah.
And also, it tells us that in the nature, there are two different types of charges.
Yeah.
Okay? There are two types of
Charges.
charges. Two types of electrification. Now, what we did, we said that the electrification of ebonite is a negative electrification.
Yeah.
And the ebonite of glass rod is a positive electrification. Okay. So, is it because ebonite is kind of black? Black is evil? That's why is it negative? Right? Why do we call this ebonite negative? And why do we call this electrification of glass positive? Is there a reason for that?
Maybe because the electrons.
It's
are
beautiful,
lost.
the glass is more beautiful, the ebonite is kind of ugly.
Glass loses electrons and ebonite gains electrons.
We don't know about electrons. We don't know that there's in nature something like electron exists.
Yeah.
I'm talking about, just think yourself to be at a place where people did not know about electrons. Okay? They knew about electra,
Yeah.
but they did not know about electron. Okay?
Yeah.
They understood how electron, the amber, behaves. They did not know that there is something which is known as electrons.
So how is it positive and negative and not negative and positive?
Yeah, that's the question. Is it because glass is beautiful? No. It is just because I had to say that either of them is positive or negative, right?
Yeah.
So for example, you look at the switch, right? When you look at the switch, if you flip it upwards, it's kind of off. If you flip it downwards, it's on.
Yeah.
Okay? That's a kind of convention that we have. We have just accepted it. Okay? When you drive on the road in Qatar, you travel to the right side rather than traveling on the left side.
Yeah.
Why is that so? Because we have to accept it. This one is right and this one is wrong. That is something which is known as convention. Okay? Not because of any damn reason we have to either say either of them is positive and either of them is negative. So there was a guy, a big scientist, his name was Benjamin Franklin. He said that, oh, Ebonite, I want this to be a negative. Everybody said, yeah, why not? Let's say that Ebonite is negative. Everybody accepted that. Okay? That's why we have this one as the negative one. Okay? And this one is the positive one. Right? So if somebody asks you why Ebonite is negative, you say because of convention. That's the answer to that question. Ebonite is negative because of convention. Okay? So a negative charge is not a bad charge, it's not an evil charge, it's not an ugly charge, it's just another kind of charge. One has to be positive, another has to be negative, right? Now, let's try to understand where these charges are coming from. When people started learning about the atoms, they understood that in atom there is something in the center of it, okay, and there's something which is going around it, okay.
Yes.
Whatever was going around it behaves like the Ebonite, and what is at the center of it behaves like the glass, okay. And when we understood that why something is charged, we understood that whatever is going around the nucleus, this thing is transferred to another thing, or that same thing is transferred into something. Due to transfer of this object, whatever is going around, this is responsible for electrification. Okay? And the one which is in the center, it doesn't go anywhere. Okay? So this one is responsible for electrification, so let's call it electron. Okay? You understand that?
Yes.
So now I guess you understand why we call electrons as electrons and why electrons are negative. Why are electrons negative?
Because they cause electrification.
Yes. And why are electrons negative?
Why are they negative? Because it's a
Of the convention.
Yeah.
Okay? You understood?
Yeah.
Now, the property of the charge is that it does not have direction. It always comes with mass. So if there's a charge, there has to be some mass. Right? And the third one is it is always quantized. Do you understand the meaning of quantization?
Yeah.
What is it?
There's numbers attributed to it.
They have to be?
There have to be numbers attributed to the mass.
No.
No.
That does not mean quantization. So quantization means, for example, if you are going to buy eggs, how many eggs can you buy?
As many as you want.
For example, give me a number.
10.
10.
Yeah.
Can you buy 10.679 egg?
No.
Why?
Because there's only whole number of eggs.
Yes, whole number of egg. So you can have 10 egg or you can have 11 eggs. Right? You cannot have in middle.
Yeah.
Okay? Have you ever seen a woman giving birth to 2.5 sons?
No.
No? Humans are produced in integers.
Yes.
Okay? Similarly, since this thing is responsible for electrification, whatever charge is carried by this thing is the minimum amount of charge that you can have anywhere. And whatever charge that you're going to have anywhere is going to be integral multiple of the charge of that one.
Yep.
Okay? So let's say the charge on this one is -2 coulombs. Okay? I believe you must be knowing that coulomb is the SI unit of charge. So if this electron has -2 coulombs, how many charge can a body have? Can a body have a -8 coulomb charge?
One body?
Any body
Yeah.
can have -8 coulomb.
Yes.
Can it have -10 coulomb?
Yes.
Can have +8 coulomb?
Maybe.
Yes. Because you know atoms
Plus
are neutral.
Yeah.
So if you are removing electron, that makes it positive.
Yes.
Okay. If you give it an electron, it makes it negative.
Yes.
Right? So if 4 electrons, let's just imagine, what I'm telling you is not the truth, because electrons do not really have -2 coulombs of charges. I will tell you shortly about it. But if, in our imagination, an electron has a -2 coulombs of charges, okay, and there is an atom which is electrically neutral,
Yeah.
and you take 4 electrons out of it,
Yeah.
okay, then it would be deficient with 4 electrons. Or we can say there's a surplus of 4 protons. Electrons and protons have the same charge.
Yeah.
So if you have a surplus of 4 protons, that means it must be having positive 8 coulomb charge. You understand?
Yeah.
So when we take electron out of something, that becomes
Positive.
positive. When we put electrons into something, it becomes negative.
Yeah.
So if there's a neutral body and we take electrons out, that neutral body becomes
Positive.
positive. Okay. If we put some electrons on a neutral body,
Something negative.
it becomes negative. Right? Now, whatever charge we are going to have is going to be a multiple of 2. Can we have a -9 coulomb of charge if each electron carries -2 coulombs?
No.
Not possible, right? So if the Q is the total charge on a body and E is the charge on an electron, we have to multiply with an integer. Okay?
Yeah.
So here you get the formula Q equals N multiplied by E. What is N?
Number of electrons.
Number of electrons that we're talking about. E,
Is the electron charge.
electronic charge on an electron. Q,
Total charge.
total charge. We cannot multiply charge on electron by a decimal number, by a number which is not a whole number,
Yeah.
okay, which is not an integer. So, what is the charge on an electron?
1.6 minus 1.6 times 10
Minus 1.6
times 10 to the power minus 19
into the power minus 19
coulombs.
coulombs. Okay. So if an electron has these many charges, how much charge does a proton have?
Plus 1.6.
A positive 1.6 into 10 to the power minus 19 coulombs.
Yeah.
Right? Now, you also have to kind of understand the mass of an electron. Do you know the mass of an electron? This is known as ME, mass of an electron. How much is that?
9.11 times 10 to the power minus 31 kilograms.
10 to the power negative 31 kilograms. And do you know the mass of proton?
No.
Okay. 1.67 into 10 to the power minus 27 kgs. Okay. So which one is bigger, 1.6 or 9.1?
1.67 times 10 to the power minus
Yeah, because that's the. We also have to look at the
Oh.
power. Okay. Now the proton is kind of much more heavier than electrons. Okay. That is what we understand about the electricity and electrons and charging. Where does the charge come from? Okay. How do we measure the charge?
Yeah.
How do we give charge to a body? How do we make a body charged? Now, the thing that we have discussed here, how did we know that charges exist? That's my question. What did we do to figure out that there is something in this universe known as charge?
The behavior between two objects.
What was the behavior? That's right. What was the behavior?
Attraction and repulsion between.
Yes, repulsion
Yeah.
and attraction. Okay. So attraction and repulsion is kind of an influence, a force. Okay. Now there is this force, right, which is acting between two charged bodies. What kind of force would we call it? Is it an electric force?
I would say so.
Yes.
Yeah.
Right?
Yeah.
It is an electrostatic force, rather, what we say. Why do we say electrostatic force?
Because They stay in one place and then they.
Yeah, the charges on this glass rod
Yeah.
and the charges on this glass rod are where they are.
Yeah.
They're not kind of moving. So we say that this is electrostatic force. Okay?
Yeah.
And what kind of influence is it? It's electric influence. Okay? Can we say that the glass rod 2 is under the electric influence of glass rod 1?
Yeah.
And vice versa. We can say the glass rod 1 is under the electric influence of glass rod 2.
Yes.
Okay? And we can also say that the glass rod 1 is in the electric field of glass rod 2. Because what is field? Field is the kind of influence that one can exert. So this glass rod can exert some kind of influence on glass rod 1.
Yeah.
Okay? What kind of influence is that? It is an electric influence. Okay? So this is the region, this is the field where this glass rod can exert an influence. If we go farther away, we see that the strength of the force decreases. Okay? So we can say that the electric field becomes weaker. As we go further, the electric field becomes weaker. Okay? If we come near to this glass rod, the electric influence becomes stronger, or we can say the electric field becomes stronger. Okay? So what we say is that in and around the vicinity of this glass rod, so if this is a glass rod, this region is the region in which it can exert electric influence, right?
Yeah.
And this region would be known as electric field of this rod.
Yeah.
Okay. Now you understand the meaning of electric field?
Yeah.
Electric field is basically the region. Now, how strongly it can exert the influence, we call it strength of electric field, or we call it electric field intensity. Okay? Now, if we go to a certain distance, then we will say that the electric field would extend till infinity, but after a certain point, it becomes intangible, like insignificant, right?
Yeah.
So after a certain point, we say that the electric field has an insignificant strength.
It is there, but you can't feel it.
Yeah. For example, is there dust in this room?
Possibly.
Do you say that the dust is causing me trouble? No, why?
There's no dust.
There must be some dust,
Yeah.
but that is insignificant.
Yeah.
So when there's something insignificant, we say that it does not exist, right? Okay. So when we have some charge on this, let's say that the charge on this glass rod is Q2, okay? So we take some point, we talk about point A, talk about point B, talk about point C, talk about point D, okay? So the Q2 charge, which is on the glass rod 2, it can influence another charge which is at A. It can apply some force on A. Now the electric field at A will be stronger than the electric field at B.
Yes.
Still, it's greater than the electric field at C. Whatever the electric field is at C is greater than the electric field at D.
Yes.
Right? Got it? So as we go away from the charge, the electric field strength becomes lesser. Okay? Or we can say the electric field of Q2 becomes weaker.
Yeah.
And the value of electric field intensity decreases. Okay?
Yeah.
Now, what is electricity? Electricity is the influence exerted by electric charges. Okay. What is electric field?
Region where
Region
there is an electron.
around a charge
Yeah.
which can be influenced by this charge. Okay. Now, what is electric field intensity? It is the strength of the electric field, how much force it can exert.
Yeah.
Okay. After a certain point, we say that the electric field of this charge does not exist here. That means that the electric field of this charge is so weak that it is insignificant. Okay. Now you understand the word field.
Yes.
Now you understand the word electric.
Yeah.
Okay. We are not going to discuss magnetic field right now. Okay. So right now, only about the electric field we are going to discuss today. Okay. And electricity.